Hello mathematicians and welcome to Is It a Function? So hopefully you have your worksheet in front of you and you can follow along and take notes with me, but let's get to it. A function is a machine. You put one value in, so we take in a value, it applies some type of rule to it, and we get a new number, one new number. This one-in-one idea is very important and is basically the whole definition, which let's fill in over here. A function is a math machine. It takes in one. So again, this one thing is really important. Let's go ahead and highlight it right here. One input. And usually we refer to this input as x. So we put in one input and applies a rule that gives out one. So go ahead, let's highlight that. Output. So this one-in-one idea is going to basically be the basis of our definition and our work. So in math, there are also these things called equations. Equations and functions look very similar. But if you look carefully for that one-in-one definition, you'll be able to tell them apart. So over here, I have an equation and I have a function. So let's go ahead and look at some similarities that we see. So I see that we have an x and a y. So it looks like it has an input and output. I also see that every x is mapping to a y, right? I do not see any y's mapping to x. I do not see it going backwards. A difference that I notice is that with my equation, some of the x's are mapping to two y's. So like right here, we see that 1 is mapping to 5. But over here with 2, I see 2 going to 5 and to 7. 3 has 1 mapping and 4 has 2 mappings. So I see that the number of mappings is different. With a function, however, I only see 1. So I see 1 only going to 5. I see 2 only going to 5. 3 is only going to 8 and 4 is going only to 6. This difference is basically, again, the whole definition of how we can tell if an equation is a function. So let's go ahead and write that in right here. A function has 1. I want you to write this really big. 1y for every x. If we have one x, it's only pointing to one y. An equation, however, can have many y's for every x. So we can see back over here that this one's mapping to the 5, but the 2 is mapping to 2 different numbers. The way I like to remember is that basically an equation is allowed to cheat. So an equation can have one x and he'll have many y's, many girlfriends. But a function is faithful. He only has one true love. He only has one y. So basically, an equation allows x to cheat. I remember equation and cheat because cheat has an e in it. So it's allowed to cheat with a lot of y's. But in order for an equation to be a function, x has to stay faithful. So a good way for me to remember is function faithful. So he has to stay faithful and have one y. Let's note that we do not care about the y's. The y's can have a lot of x's. We do not care about them. We are not in y's business. We only care about the x. X cannot be a cheater. He has to have only one true y for it to be a function. Function faithful. So there are different ways we can check if an equation is a function. So on to the next page. There are different ways to check if an equation is a function. So there are equations that are not functions, and there are also equations that are functions. So let's start off with this first one, looking at maps. Let's look for cheating x's. So the steps. we're going to look for any x's that are mapping to 2 or more y's. We're checking for any cheaters. So it's just kind of like the last page I just did. So let's start off with this mapping. I can see I have x's and they're mapping to y's. So let's check if any of them are cheating. This 1 is only mapping to 6. He is faithful. 2 is only mapping to 6. Also faithful. 3 is mapping to 7. Okay. 4 is mapping to 8. I see no cheaters. So I see that this equation is faithful. So it is a function. Let's look at example 2. This 1 is mapping to a 5 and a 6. Right off the bat, we have a cheater, you guys. Oh my God, the audacity, right? So you might be saying, whoa, but 2 is not cheating. It does not matter. As long as we have one cheater in the equation, the whole thing's a cheater. So this is not a function, it's cheating. So, oops, I'm going to say not faithful. But I give you the answer. This is not a function because 1 is cheating right off the bat. And that's it. So go ahead and give the next section a try. You might be thinking, that's it? Yeah, that's pretty much it. And I'll see you for the next video.